Anupam madam, have you joined? ಏನು ಹೇಳಿ? Good afternoon all. I hope you are able to hear my voice. At least one yes from your side. This is streamlined on YouTube. You can watch. Today, what I want to say is that at least last class we discussed about the data analysis part. Today, let us see that how that data can be analyzed in a different way. See, this is the case. Plotting of the data, particularly for different purposes. Analysis of basic data and plotting of mathematical functions. You have seen that several mathematical functions which are available to you for plenty of use. Analysis of basic data in the sense, data varies from person to person. Data also varies from application to the applications. Whether it is for a laboratory class from physics background, either for thermal experiments or maybe an optical experiments or maybe an chemical experiments from chemistry or maybe an any plant samples or maybe data which is extracted from the oceans or the data which is retrieved from the satellites, the data which may be retrieved for any celestial objects. Maybe for example, how that the sun emits radiations for every moment, either in terms of every second or maybe every moment, like in minutes, how that data can be plotted. What are all the functions which are available? Analysis of basic data goes with the four modes. Okay, can generalize. It is a general way. It may be in further modes also to a great extent. For example, how one can go for the plotting of a straight line. Instead of saying that it is a plotting of the straight line, how a data can fit into a straight line, or how our experiments are valid for the linear fit. If they are with linear fit, if they are the linear mode. If they are not linear, if they are not having a regression mode of that kind, regression is the best fit line actually. If there is a correlation between the two, like for example, y is equal to mx, what we discussed in today's class actually, if the x value increases linearly, y also may increase linearly or may not. If they depend on each other with linearity, then certainly the line can be said to be a best fit line. We'll go through some of the examples, then you can see that how that can be done in a better way. For example, plotting of a straight line, how they can go. I'll go through the text, then you can repeat it in a different way. Then we'll see that how that best things can be done. Uh, what what normally has to go is that the basic purpose of plotting is to figure out the mathematical connection between the two different physical factors or with two variables where the variable you are mentioning on y axis should depend on the variable which is having on the x. Otherwise, while plotting the graphs, the x should be an independent, y depends on the x. Means the parameters which are not, which are fixed, which are variable, which are under your control, which are under the control of the experiment, for example, like change in the voltage, how that current changes, variation of I versus V, variation of current versus voltage, variation of temperature, maybe with the variation of the temperature, maybe with time, variation of density with different samples, variation of what we can call variation of variation of any of the variables depending on the time parameter actually. Graphs are effective tools what we are plotting so far and what we are going to utilize it actually for tools for illustrating such linkages, that is the linkage between a physical phenomena which is happening and the phenomena which is under the control. These mathematical equations, mathematical representations, mathematical tools for example are the best one that can signifies the results, that can signifies the predictions, that can signifies the amount of knowing the links between the phenomena which are happening. Plotting such type of a graphs, for example, gives us a visual, of course for you also, visual representation of the data and plotting of or following of any of the trends. Maybe a trend may be a linear, trend may be a logarithmic, trend may be an exponential, trend may be an sinusoidal, trend may be something else. Secondly, or the second point is that they provide us the capacity to determine the consequences of any system modifications through suitable analysis. In graphical analysis, what happens? Transforming the experimental data into a straight line, or if it fits with the best fit line as a straight line, is an essential approach. If it follows, then we can able to see the trend, how it moves. If there is such a relation, maybe a direct relationship, or maybe a linear relationship, or maybe a direct collection, or maybe a linear connection between the two such type of variable parameters, the data might be fitted into the equation of the line with the common form like y is equal to mx plus c using a technique known as the linear regression. The line which fits is known as a straight line. How you can connect a straight line? To draw a straight line, it requires minimum of two data points. Minimum of two data points. You can always connect the 2 points by a straight line. If there are 3 points, then it is difficult, whether maybe a straight line or maybe a zigzag or maybe a non-linear curve of that kind. Which is the best fit? That one has to be decided by different techniques. One technique is known as the linear regression technique. I will not go and explain the linear regression here. How that linear regression makes the best fit line, that we'll try to do that. This equation expresses, there is the linear regression equation expresses the mathematical relationship between the two variables that can be plotted and allows us for the prediction of unknown values within the parameters. Y is equal to mx plus c, provided the line should not pass through the origin. If it passes through the origin, or if the intercept is meeting the origin, then we can say that y is equal to mx. If it does not, then certainly the line will never pass through the origin to a greater extent. Let us see the data, how that data can be done. Here, we are having some set x and y. Y depends on x value. Assume that x varies like 1, 2.3, 3.1, 4.8, 5.6, and 6.3. Value of y is that 2.6 corresponds to 1. What it is plotted on a dot here. 2.6 corresponds to 1. Then 2.8 corresponds to 2. Maybe 3.1 corresponds to the 3.1. Exactly matching. Okay. 4.8 corresponds to the 4.7 corresponds to the 4.8. 5.1 corresponds to the 5.1 corresponds to 5.6, 5.3 corresponds to the 6.3. If you plot the graph and change the best fit lines depending on the variable data, I will show you in the demonstration how it looks. What happens here? Observe here, there are different dots. You want to connect. Where to connect? Between these 2 points, this is the best line. Here another line, here another line. You can go on connect between these 2 points. That is not the best point line. How that value of y varies with x can be appointed. See that the first point is above the best fit line. Second point is well below the best fit line. Third value is also well below the best fit line. If you see the data, 3.1 both are matching. If the value of y is 3.1, x is also 3.1, but still best fit line does not pass through the point. They are above that. It is an weighted average they can call. Or the best fit line is plotted in such a way that it should have a minimum deviation from the point means is the dots are the experimental, dots are the truth, dots are the validated points, should have the less deviation from the best fit line. Okay, in fact it is passing through only 1 or 2 points here. Actually rest of them it shows. Least square fit method they can call. It should be the minimum of deviation of the square of the difference between those two mean and the actual values gives us the best fit line. We took it as in 6 examples. Here you can see in the fit actually y is equal to some equation. Equation you can't write actually in principle, but there is a possibility to estimate. Y is equal to m times x plus c. Intercept is the c. If you extrapolate it, it will come to be around 1.68 so much of the value. And value of the slope should be around 0.58. These two you can expect. And if that is the case, if you know this best fit line with best fit line And also the trend, this is the trend how it moves. How, what it says that as the x increases, y also increases, maybe linearly, yes, certainly it increases linearly. What is the expression? This is the expression what we got it. If you want to know what must be the value of y for a given value of x is equal to 4, you can't, but you can estimate when x is equal to 4, when x is equal to 4, 4 times 0.5 to 2 plus 1.6, for example 2 plus 1.6, that is about 3.6. 3.6 comes somewhere here, see that, but here it is there somewhere here, in the sense this is exactly 4. 4 matches with the 4 because 0.458 is there, 0.58 is there, that can match. Okay, what will happen to the value of what 1.5? What will happen to the value of y for a given domain of about 1.6, 1.0 to about 6.3? But the thing is that from the best fit line, we are not supposed to estimate the values or predict the values or determine the values beyond this set. The estimation is valid only between minimum of x, y and maximum of x as 6.3. Within this domain only this best fit line meets. For example, if I want to estimate what must be the value of y for a given value of x is equal to 7, even though you may be able to estimate, but that is not the good sign. The seventh point or the seventh observation may go up or may go down or may change. You may get a peak, you may get a crest. That is the limitation. Means the best fit line or the best fit line should be valid only within the data domain. That domain should be whatever the domain we have observed. This is how it has to go. We will see one after the other. I'll come back after repeating the two. Then plotting of the logarithmic and exponential functions. Okay, plotting of logarithmic and exponential functions using any spreadsheet you can use without computer aid. Also, you can plot. For example, log x how it looks, sin x, e to the power of x how it looks, a to the power of x how it looks, b to the power of x how it looks, x square how it looks, x cube how it looks, 2 to the power of 3 how it looks, 2 to the power of 7 how it looks. They are these constant points. 2 to the power of 3, 2 to the power of 7, they are constant points of that kind. Let us see that how it varies logarithmically. For example, a function of the form f of x is equal to a to the power of x. If a is greater than 0, sure, it should be a positive integer. Okay, need not be, even for float also, sorry, fractions also you can take as 2.1, 5.8 of that kind. And x is also an integer, only for our convenience. Such a function is called the exponential function. One can take three different cases here. If a is equal to 1, one case, 1 to the power of x, or a value lies between 0 to 1, means a is greater than 0 and less than 1, and a is greater than 1. Where is equal? A is equal to 1, already we have taken. It means to say that 0 is less than or equal to a is less than or equal to 1, it stops. But a is also greater than 1 is an example. If that is the case, if a is equal to 1, then what will happen? F of x is equal to 1 to the power of x. 1 to the power of any value is 1. So this just gives us the constant function f of x is equal to 1 as a straight line. If x is equal to whatever the value, you will get the f of x as the 1. What happens if a is greater than 1? Then, for example, if a is greater than 1, let this be a 2, for example. F of x is equal to 2 to the power of x. 2 to the power of x you have to plot. 2 to the power of x means if x is equal to 0, 2 to the power of 0 is 1. If x is equal to 1, 2 to the power of 1 is 2. If x is equal to 2, 2 to the power of 2 is 4. If x is equal to 3, 2 to the power of 3 is equal to 8. In the sense, it varies. It varies. How it varies, we'll see that. Is it an exponential or not? 2 to the power of 0 to 2 to the power of 3 within that domain only. Or if x is equal to minus 1, there is also a possibility. 2 to the power of minus 1 becomes half. 2 to the power of 2 becomes 1 over 4. 2 to the power of if x is minus 3, 2 to the power of minus 3 becomes 1 over 8. We can put these results into a tabular column and plot the graph. Like minus 3, for example, minus 3 corresponds to 1 over 8, minus 2 corresponds to 1 over 4, minus 1 corresponds to 1 over 2, 0 corresponds to the 1, 0 corresponds to the 1, and rest of them. Choose any data sets. This one example that is showing that variability of an exponential function. If it goes like this, see that how it varies. Sorry. Oh. Here, when x is equal to 0, y is 1. Okay. When x is equal to 1, y is 2. When x is equal to 2, y is 4. When x is equal to 3, y is 8. That is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. If 2 to the power of minus 1, half, 2 to the power of minus 2, 1/4, 2 to the power of minus 3, 1/8. This is the line. Along with that line, it is also shown a dark line with a solid line that is connecting between the 2 points. This is not the straight line. This is not the best fit line. It shows a function which is an logarithmic in nature, how that function has to vary. If we go with the function like an exponential, for example, it is shown in dotted line. You see that here, the dots are matching here, the exponential of 0.6931 to the power of x or 2.8 to the power of, instead of 2 to the power of x, 2.8 to the power of 0.693 also gives you this variability, this variability. This is for the 2 to the power of x, 2 to the power of x. Still, this example you try, and later you try with the different functions. For example, at the left hand side you see here without the tabular column, see that, sorry, this is the x value, this is the x value, and these are the function f of x. F of x is equal to 2 to the power of x, looks like this, what we shown here, this one, 2 to the power of x. If f of x, if this value is taken as 5, instead of 2 to the power of x, let it be 5 to the power of x. See that it has to have this line, see, coming and going like this. If it is f of x is equal to 10 to the power of x, this is the function it can go. Instead of that, let us choose another point here, minus 3, 8, 2 of that kind. Okay, instead of x as minus 3, x as minus 3 here, x as minus 2 here, x as the same case, sorry, instead of 2, let us choose 1 over 2. 1 over 2. If it is 1 over 2, for that 1 over 2 to the power of x, the function looks like this. The function looks like this. In mathematics or mathematical physics or computer programming, computer knowledge, numerical techniques, they handle with this type of functions, and you should aware of how that function varies. If you know the function, or if you know the trend, if you know the curve, you should be in a position to decide that what kind of a curve it was, or what kind of a curve it will be. This is another example showing that. Okay, don't get nervous. Okay, all points are meeting at one point when y is equal to some kind of a value they can call. For example, this is the line which was shown familiar, 2 to the power of x. This is the line shown for 5 to the power of x. Fine. Instead of that, if you take it as a reciprocal of that value, 1 over 2 to the power of x goes in a reverse order, 1 over 5 to the power of x goes in a reverse order, and all 4 lines meets at one point, one common junction. This you can do that. Means go for the x value. Let us choose the x value from minus n to plus n instead of having a larger values. Let us choose some smaller values, about minus 5 to plus 5 or minus 10 to plus 10. X value should be minus 1. Then see, for example, while making calculations, you use the examples of minus 3 to plus 3 of that kind. While giving it to a computer, let us choose from minus 10 to plus 10. May not be even an integer of value. Maybe minus 10 to plus 10 with variability of every 0.5. You put one column and try to estimate what must be the value of the f of x, if it is a 5 to the power of x, or 2 to the power of x, or 1 over 5 to the power of x, or 1 over 2 to the power of x. How this function looks. If you are taking for small interval, then the line should be smoother line. This is the second example what I want to convey. Third one is that you can also go for trigonometric functions. How one can plot the trigonometric functions actually. Here, my intention is that, okay, let it be only for up to 45 degree or 90 degree, not an issue. Angles will be 0, sine, cosine, tangent. You can plot. There are some packages like in a spreadsheet, may not be with Excel or maybe some other kind. If you put sine x, immediately it plots the sine curve. If it is cosine, that will also plot the cosine curve. If it is tangent, that will also be plotted. Or the combination of all of them put together also can be plotted. Maybe sine x square plus cos x plus tan 2x, or maybe sine 2x plus cos 1 over x, 1 over 2. 1 over 2 times x, any functions, any combination of the functions can also be plotted. Thing is that the limitation in spreadsheet, particularly in Excel, is that it may not convert, it may not take the values directly the angles. All the values whatever we are putting are in radians, and the values should be in radians only. Here I took the example in such a way that let it be 0 to 360 degree angles theta value. For every 15 degree, let us try to estimate that how that the functions changes. Assume that you have to convert this angles into the radians 5 times. 5 means that is 3.142. 5 times the angle over 180 gives you the actual value. Means sine 0, sine 180, sine 15. These are the signs. Sine 0 is 0, you know. Sine 90 is 1, you know. Sine 45 is 1 over root 2, you know. Cos 0 is 1. Cos 45 is 0.7, 1 over root 2. Cos 90 is in fact 0. Because of the small fraction, you are getting it as 0.2 followed by 3 zeros followed by 2. Tan also the same case. If we extend this for up to 360, it doesn't matter, you'll get a good tabular column of this kind. Okay, this is in radians, this is in degrees, these are the values. Cos 360 is 1, cos 180 is minus 1, and sine 90 is sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is 0. Tan, in terms of the tan 90 should be about some other relative value, and like that you can go for the plotting of the tan also. Here if you plot them, this is how that sine curve looks. Here I made a mistake in the sense that the increment is not in terms of interval of the degree. 50, 100, 150 it is there. I could have been stopped. Increment you can keep it for every 60 degree, or about 180 degree, or about 30 degree of that kind actually. This is how that sine curve looks. This is how that cosine curve looks. Cosine starts with here and ends somewhere else. It is not the anti-clockwise. There is a lagging actually. Okay, lagging by almost about 120 degree between these two things actually. When this is the maxima for 100, the maxima you are getting at sine cos 0. Similarly, you can plot it for transcendental functions or transcendental equations. I hope you got up to this extent. What I will do, I will explain this phenomena one after the other. Let it be a first case with the linear fit. Then x is equal to this data point is there. What I will do, here already data is there. Okay. I will show you from the beginning. This is the data for the sine. Let us choose the data set. Okay. Here and plot. This is the x value and this is the y value depending on that. If there are more than two variables, it is better for you to name the columns. X is equal to temperature, y is equal to data, or y is equal to voltage, x is equal to current of that kind. Select these two data sets. Okay, our intention is to plot a scatter curve. This is a similar way how you are plotting. Go to the Excel, same case, insert, okay, plot charts. You can choose any one, doesn't matter. See that this, okay, these are all the available things. Okay, here I will choose this scatter plot, and also with the line. This is the, it connects between the lines. If you plot, this is the linear fit I want to check actually. Okay, linear fit I want to expect. Linear fit, how I will do it. Okay, here's the thing. Here you can change the line, automatic, width of the line, and other things also you can change. That is only for the beautification. This is the x and y axis you can plot, and you can name them also. What should be there on the x axis, what should be there on the y axis of that kind. Labeling you can find here. You click on the data points or the data curve. Okay, here what it says that this is the fine, add trend line. Okay, here it shows that. I don't know whether you can able to see in your display. This is how it has to go. Okay, there are different things. One is that linear it has already plotted. This is linear, it has already plotted. If you want this linear for this curve, instead of the points actually, see that this is the exponential. What I want to say is that here you don't connect between these 2 points, connect these points, let it be a scatter curve. Change this to the scatter curve. One second. choose this, go for insert, data, scatter. Okay, here come for the plottings, right click, add a trend line. Okay, here there are variable trend lines because there are plenty also. If it is a linear, for example, see that this is the line it has to show. This is the what I explained for you when I was explaining the text. In the sense, if not linear, let it be an exponential. This is the exponential line. I don't know whether you can observe it or not. If it is a linear, this is an exponential, and if it is a logarithmic, see that logarithmic has to look like that. If it is a polynomial, the function look like that with the two orders. If you are increasing the order, third order, see that points are merging. If it is a fourth order, still merging. Fifth, sixth order, still merging. So six orders are there. Means you can choose whichever with the order you want. Accordingly, the points will also change. If it is a power like 2 to the power of x, 3 to the power of x, how it has to move. If it is a moving average, means normally you can choose 2-point average. 2 points are average and plotted on the next point. 2 points are average and plotted on the next point. 2 points are average and plotted on the next point. If it is a 3-point average, 4-point average, 5-point average you can call, 6-point average if you go single line of that kind. Okay, mine you can choose anyone. Even let it be linear here. This is a function, and either you can choose custom or maybe automatic. This is the automatic. While plotting also, set intercept if you put, see that this is the set intercept. The set intercept is the plot. Set intercept in the sense the line will pass through the origin. Means you see that the plot without intercept, it may intercept somewhere else here. If you set the intercept to the 0, it plots. Means the line will be different. Display the equation on the chart. Certainly it will display the equation. This is y is equal to 3x. Y is equal to 0.7 times cx. This I will increase. Show you. Okay, this is for the case. In the sense, in the sense, see, this is the second case. If you set intercept does not match, display the equation, fine. Set intercept is fine. If you remove the set intercept, then display the equation. See that this is the equation what I got it. Y is equal to 0.58 times 1 plus. This you can also do that. How you take the slope and estimate the intercept, extrapolate it till where it meets the y-axis, maybe positive y-axis or negative y-axis depending on the property. It has to show. If once it shows, you can have the guess. You can also have the best square or squared value they can call. What must be the regression? Regression is 0.5 in the sense 50% the values are matching more or less. Another 50% doesn't have an agreement. Means 51.86% is the agreement between the y values. That varies how the 50% is the agreement with the theoretical line what we have drawn as 0.5842 times x plus 1.6842. This is how it has to go. Remember, for this extent, then we can change. You can choose it for exponential, for example. See that immediately equation also got changed. Okay, best fit line also changed. If it is for logarithmic, it is so dynamic. If it is logarithmic, equation also got modified, and this also equation modified. This equation you remember, whatever the equation is modified here. Okay, then sorry. Logarithmic you can choose, polynomial you can choose, power you can choose. For example, polynomial if you choose set intercept, display, equation, all of them they are varying. Moving average is a different one. Moving average also gives you the equation of that kind. This is for the what we can call for the one set of an equation for the linear fit. As far as the second one goes is that plotting of a logarithmic and an exponential functions. This also you can choose here. The data points are chosen in such a way. Here let it be an x value like this and y value like this. 1/8 becomes 0.13 that I wrote. 1/4 becomes 0.25, 25%. 1/2 becomes 0.5%. Choose these two values. I plotted and shown the same graph for you. I will also show you right now with the new table. Here, if it is the case like this, Okay, like this. Plot this 2 by connecting a line or maybe through a line. Choose, see that how that x varies. Go to the point, double click on it, tab, add line. See that this, if it is a straight line, it has to have the same case. Let it be an exponential, matches well. If it is a logarithmic, it is not a good idea. It is not a good idea to choose it for logarithmic. See that format chart area. You can also choose polynomial. See that polynomial of higher order, certainly it matches. Okay, then power. No, power in the sense it is not. Okay, it is not 10 to the power of something like that. If it is exponential, goes well with that. 2 to the power of x with values of x changes from -3 to +3, how the function can go. You can also set intercept for this equation. You can also display an equation here, y is equal to e to the power of 0.693. You can also go for the r square because it is exactly exponential. Both are matching and correlation is 1. R square is the measure of, or correlation is the measure of how best the values of y are matching with the x, particularly in a trend line they can call actually. If that is the case, during some times you will find the unknown values corresponds to the x by knowing this type of an equation. That is the beauty of mathematics. Great thanks to the mathematicians who have worked out well for us. Clearly, 2 to the power of x. See that 2 to the power of 0 is 1, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 3. The same functions we have plotted. If you plot that, you got this equation. At the same time, I have shown here maybe 5 to the power of x, maybe 10 to the power of x. The same thing you can do that. How we can do? Next cell, this is the case. This is the case. Instead of point somewhere here, you choose the values 2 to the power of x, 2 to the power of, sorry, plus 2 on square root caret this. If use, it will come 0.125, 2 to the power of. If prolong it, it gives you this case. 2 instead of 2 to the power of 5 to the power of plus 5 to the power of this value. Okay, then go with this, maybe 10 to the power of 10 to the power of 10 to the power of this value. Go like this, 0.01. See, means to say, I'll erase here, I'll plot the entire plot. See that this and this, they're one the same thing. This, where all of them put together, if I connect with the lines, it should be the replica what you got out of it. Here, what it is showing, the same case, how it is showing. But why it is different from that to this? Because there should not be a power to a great extent. Okay, means you can go here. Format axis. See that how it has the same case. This is the line it has shown in a logarithmic. How it has to be means what I want to say, while plotting, instead of choosing these values, you can choose any fractional. Instead, see for example, minus 3, I told 10 actually, in the sense, minus 10, minus 9.75, okay, then drop down till to the extent, sure, 9.5, trend is followed, go to the extent of, let it be 100, doesn't matter, okay, because computer will take care of everything. Here plus 2 to the power of 2 to the power of 2 to the power of this value, 2 to the power of minus 10, maybe decimal number should go up, Here, the values are coming with a higher order. Okay. See that you just prolong it till to the extent wherever you got it. Let it be around 100. But thing is that 2 to the power of 100, see that such a high number, such a high number, such a high number. Still you can plot. Still you can plot. Go insert. Fine. Fine. How the plots are looking. See that this is how. This is how it looks. Take one tab. Add trend line. Linear is not defined. Exponential, sure, matches. Maybe with set intercept, no. Display equation, yes. Display R square, yes. But Y values while plotting, it has not shown properly. So much of values are there. We can mention them in a way. So much of higher powers are there. We can choose it as a logarithmic scale. See that if it is a logarithmic scale, it looks like a straight line. In the morning class also I told that the logarithmic with linear values looks like that. It is the scale is logarithmic. Values are increasing in such a way, increasing only with increasing in value of x. It looks like a linear curve. If not value in reverse order also you can do that. This is the reverse order. There are several variations actually. And while number formatting, you have chosen this as a decimal point. Instead of that, you can also choose the number point as the exponential number, time, date, number, decimal places. Let it be only a few negative numbers. Yeah, you can choose the 10 to the power of 10 to the power of also you can choose. That is also possible. That is also possible. Oh, choose 10 to the power of X. Format axis, format major grid, format axis, minimum, maximum, axis value, display units, base 10 it is there, base 10. Yeah, you can use 10 to the power of 1, 10 to the power of 2, 10 to the power of 3 as a scientific options. That I will show you somewhere else. It is there actually. You can also plot the area, how it has to look within that. This one case. This one case actually. After that, you move to this. This is showing that all the possibilities of the values, how it can choose. Like 2 to the power of x we have taken. Like 5 to the power of x and 1 over 5 to the power of x I will show you here. Okay, at least for the data sets. Let it be about -3, -2. Okay. This is for 2 to the power of x, 2x, 2 power x, for example. For example, 2 to the power of x. Okay. Let us choose for 5 to the power of x, then 10 to the power of x, then 2 to the power of 1 over x, sorry, 1 by 2 to the power of 1 over x. Here they will choose that 1 by 2 to the power of x to the power of x, or then 1 by 5 to the power of x, then 1 by 10 to the power of x, 1 by 10 to the power of x. Okay, let us choose only this number, only this number. Okay, if this is the case, if this is the case, 1 second, I will highlight this. Wow. Okay, 2 to the power of x I plotted. 2 to the power of. Let us choose this. 2 becomes, it should be 5. 5 to the power of x b2, sorry. Okay, 5 to the power of 5 to the power of a2 only, a2. Then this is power is 10 to the power of a2. Okay. Here 1 over 2 is there. How 1 over 2 we not to write? You have to write, use the bracket 1 by 2 to the power of, to the power of, to the power of, again a2, fine. Then 1 by 5 to the power of, 1 by 5 should be within the bracket, to the power of a2, fine. Then 1 by 10 should be 0.1 also you can use. Instead of that, you can use it as 1 over 10 to the power of a2, fine. Means here for these two, no need to go for 4 decimal. Let it be in only that number because numbers are quite larger. If you extend this to a greater extent, sorry, even 0.2 also should be used. My God, see that here? Yeah, here also no need to go up to that extent. You can reduce here maybe 2 decimal. 2 decimal. Fine. This is how. This is the value. What happened here? Yeah, yeah, fine. This is how. If I plot these things put together, okay, what you are expecting? You should get curve like this. Should get curve like this. Okay, if I plot here only line with the insert and power, okay, it's not showing, not showing, not showing, not showing. Why? Because x is fine. What happened to the y? Y is not of that kind. Y varies. See here. Then you got the idea. It is inverted, of course. It is inverted. It is inverted. This is the similar curve. What you got it for the function actually. X is fixed. Y is changing. Okay. Means because of that, what you got? See that. This is how it has to vary. This is for the blue. Of course, you can label it also. Format change. Format secondary axis not required. Add 10 line. Add labels. This is the points they have put. This is the series 1, 2, 3 is there. Series, instead of series, we can call this as the power. This is the 2 to the power of x, first one, 2 to the power of x. Second one, 2 to the power of 5 to the power of x. This is maybe the third one. Okay, like that. You see that. If you click on that, it will show that which is the plot. Okay, means which is the plot. This is for this row. Column wise also you can choose how it can be done. How it can be done. Here, page insert plot plot scatter add format axis logarithm values. See, if both are logarithmic, the axis looks like this. These are the different versions. These are the different versions. Right now, for time being, you practice up to this extent. Then the plotting of the trigonometric functions I have shown. Maybe make use of the same thing here. Sine cos, like what I plotted is that for sine and cos. See, this is the sine value. Angles for converted into the angles are in radians are converted into, sorry, angles are in degrees converted into the radians, then sine, cosine, tangent. This just I put sine of the angle, cos of the angle, tan of the angle. You got the values. You got the values. Tan B39 is fine. Tan 45 is 1. Okay. Tan 90 should not come. It is an infinite value. Okay. And that's why the values are erratic there. Here this value will not come. Tan. How that a tan function looks? See, for example, I will plot for the sine. Let it be here. Sorry. No, I will choose this. Plotting, I will go for the new page. New page. Fine. This is not required. We just these two. Go insert west page. Sine. This is how what I made a mistake at the time was what I shown here, sine curve. See, this is not in radians, it should be in degrees. Label should be for every 30. This you have to take care. Format axis. This is the axis. The major, minor, minimum is fine. Instead of that, you can go for 360. Okay. Unit wise for every 60 you can use. That is 4 comfortable. More comfortable. See that every 60, or you can use every 30. See, 0 degree, 30 degree, 60 degree, 90 is the maximum, 180, 360, how it has to go. Or you can use 15 also, doesn't matter, but you will get more points. More points. But your points are for every 15. For every 15 it is there, you can mark it. You can mark it at least. Otherwise, one subgrid is there, subgrid will not come into the picture. 30 is fine, 30 is fine. Major grid is for about 15. Fine, this is fine. 15, 30, 60. How it has to go? Can you go with the trend line? Yes, there is no doubt. Here, if you click on that, add a trend line. It is only going with the linear. If it is a if it is a linear, you may not do it. You will get only one straight line. One straight line. Here, linear. This is the line. What I want to show you here. Okay. If it is a logarithmic, no chance of the logarithmic. Function does not follow the logarithmic. Should know. Then maybe moving average is fine. Display equations on a chart, fine. This is for the linear. It should not be linear. Should not be of that kind. Without that, this you erase it. This should not be there. This you erase it. We'll go with the sign. Can you have the trend line for that? Yes, a sign equations has to come. How that sign equation will come? That you can have it. Similarly, for the cos also you can do. Cosine, how it looks? I'll show you cosine. This one for the angles. This is for the cos. You plot them. Okay. This is, and how you are doing it on a what we can call computer. That you have to do it manually to get acquainted with these things. Then you can plot using any of the softwares. That's fine. This is how that cos looks like. It is not exactly anti, but if you plot both of them put together, sine and cos to a great extent, I will erase this. My God, go please. Erase in the sense I will delete this file. Use this both together, sine and cos. What you will get? You can expect sine and cos are anti. See that? In fact, they are not exactly mirror images. Okay, as the sine goes up, cos starts with 1, cosine decreases. See that? There is a lagging. Lagging by how many degrees? That you have to notice. While noticing lagging, you can make it as for let it be for every 30 and the maximum value let it be 360. Should not proceed much. Okay, lagging how much actually? Where you are getting peak is here. Peak is here. This peak is here. This 180 to 90, almost 90 degree lag. 90 degree lag. In fact, you got this 90. This is the beginning. This is the maximum value. 90 degree lagging between sine and cosine of that kind. Sine and cosine of that kind actually. Like similarly, if you plot it for tangent, don't know whether we'll get it or not. Somewhat difficult task for plotting the tangent line. Tangent line with this. See that how the tangent line looks. How the tangent line looks. Okay, this it has to go. Tangent line should be of this kind only. It is not of the same kind. Means ratio of sine over cos gives you the tangent line. Tangent line looks like this. This is the tangent part. Nowhere you will get the connectivity between these two. Similarly, after that, plotting transcendental equations, for example, transcendental equations, I will show you. You try yourself at least. The equations of the form when f of x is equal to 0, where f of x is purely a polynomial, when x is equal to, one second, when x is equal to, when a polynomial in x, that is x to the power of 6 minus any kind of equation is known as the algebraic. But if f of x also involves with trigonometric, arithmetic or exponential terms, then it is called the transcendental. If it involves, this is the direct algebraic equation. If it involves either the trigonometric functions like sine, cos, tan, or hyperbolic, or inverse of that one, or any arithmetic operations or an exponential form like an e to the power of x, x to the power of x, or logarithmic, we call them as the transcendental. For example, x times e to the power of x, or x log x, or these are some of the examples. You choose any coefficients to plot. That may be a good idea. For example, even I told the estimation of the functions for any of the mathematical tools. If I go with something like this, for example, force due to gravity. For example, F is equal to, I will write the expression, F force is equal to M1, capital M times M, M times M over R square. Okay. What you will do, you should know the value of mass of M and mass of another object M and distance of separation R. Okay. Constant, anyhow, you are well aware. Constant is that, what is that constant? 6 into 10 to the power of 6 into 10 to the power of 11 is the G value. 11 is the G value. Even though it looks an higher value, it looks like that. 10 to the power of 11. For example, if you want to estimate the thing, how it can be done, that I will show you right now. You put the mass in terms of the kilogram, let it be 1,000 mass. Okay, every time 1,000 kilogram is the mass of the heavier object. Smaller mass varies from 10 kilogram to about 100 kilogram, for example. Okay, keeping R as the constant of about some 100, how you will estimate this force? For example, this is a mass, this into this, okay, divided by, open the bracket, this square multiplied by this constant, what you expect, this constant you get 6 into 10 to the power of 11 should be the bracket, you'll get somewhere. This is same case, because these are very minimal, you'll get of the order of about 10 to the power of 11 to a great extent actually. Okay, means if you change the R value, or if you keep the same R value for all of them, try to estimate this formula. You can estimate. See that values are changing to some extent actually. Instead of that, you can also calculate this for any variable quantity to a greater extent. Whatever you are doing the experiments from your electronics lab, general lab, optics lab, or such type of an examples you choose, or you may have the examples from numerical examples from the theory part. Okay, you bring those examples in a tabulated format, or try to estimate using the formula. Then you will come to know that what best we can do it at least. This is fine. Good example how one can do that. Any equations can be written in the spreadsheet or Excel. This is easier. Then you can use it for the plotting between those things, how they are related. Means I'll stop showing this Excel file for you, and this is not required. And we can go in such a way, where we are trying. This is the transcendental equations you try, and we will have the beautiful things actually. Then if you know all type of analysis, this is good enough for us to estimate the analysis of basic data and plotting of mathematical functions using any of those things, either from Excel in Windows system, or maybe a similar spreadsheets are there in your Linux systems, or you can use any other tools like R, or maybe statistical tools like packages, SSPS, or maybe some other tools are also available, or simply you can plot them on a graph sheet and analyze in all respects. All aspects. Good. Thank you. And if you're having any query, I'm happy to answer. Otherwise, you listen to me, listen this, and attend the laboratory sessions